Good morning, ladies and gentlemen. My name is Dr. Muhammad Abdurrahim. I'm talking to you from Sharm el-Sheikh, Egypt. I'm going to talk about aerosol delivery to critically ill patients. Let me switch off the camera to continue my presentation. Okay, our talk today is about aerosol delivery to critically ill patients. Aerosol delivery to spontaneously breathing patient is just delivered normally by meter dose inhaler, dry powder inhaler, nebulizer, or even injection or oral dose. You just inhale the dose in and they have a guideline. But what about ventilated patient? Ventilated patient get their aerosol delivery by nebulizer, different type, vibrating mash nebulizer and jet nebulizer, a meter dose with different adapters set within the circuit. They assume equivalent, but however, in 2010 we compared vibrating mash nebulizer to jet nebulizer. We found a huge difference. 2 mg delivered by vibrating mash nebulizer is equivalent to 5 mg delivered by jet nebulizer, so no equivalent at all. We even extended our study to human in 2011, and we found that the lung deposition and systemic bioavailability is very hugely different, so no equivalent at all. We compare all nebulizer to each other. We compare all meter dose with inhaler with spacer to each other. We even compared nebulizer to meter dose inhaler. We adjusted those, but we found that big difference in another issues like patient interface, patient related factor, by ventilator related factor, pressure assisted or volume assisted, circuit related factor, single limb or dual limb. All this are factors affecting aerosol delivery. So where's how to use the aerosol generator in a ventilated circuit? Where's how to choose them? Where's how to place them within the ventilation circuit? Where are the guidelines for all this? No recommendation or guideline for ventilated patient aerosol delivery. Most of the respiratory service read literature and decide upon, which is risky actually, because some patient may have a subtherapeutic dose and some patient may have a toxic dose. So we decided to point out the weak point to initiate the production of guidelines. Factor affecting aerosol delivery during non-invasive ventilation are type of aerosol generator, nebulizer mode, aerosol generator position within the ventilation circuit, nebulizer Z volume, humidifier, gas density used, patient interface, aerodynamic character of inhaler aerosol, patient position, ventilated related factor. Type of aerosol generator are lots. For example, we have a meter dose with adapter like A, we have meter dose with spacer like D, E, F, we have vibrating mash nebulizers like B, we have a jet nebulizer like C, which actually affect the setting of the ventilator as well. We have something like G and H, which is a device used to deliver meter dose inhaler and nebulizer at the same time, assuming that giving the patient two puffs from the meter dose inhaler before nebulization increase the delivery of the nebulized dose. That was actually obvious in dual limb circuit. However, in single limb circuit, it wasn't. We tried both the small and the big one, but it didn't work in the single limb ventilation circuit. That difference should be further studied, because what make the single limb different from the dual limb action? Nebulization mode, of course, you'd better use nebulizer or meter dose inhaler that release the aerosol when the patient inhale the dose. So synchronizing with the inhalation. The faster the setting, the better the aerosol delivery to the lungs. So we'd better use synchronized or intermittent nebulization that release the aerosol when the patient inhale it. The place or the position of the aerosol generator, like you see in the figure, the aerosol generator are placed in the dual limb in the inspiratory limb, and the single limb placed next to the patient. So the smaller the dead volume of the TPs, the better the aerosol delivery, especially to single limb patients. Nebulizer dead volume, we have two nebulizer actually used with these patients. Vibrating mass nebulizer, which have a very small dead volume around zero point 0.1 milli, and jet nebulizer, which have about 1 milli or half milli dead volume. So try to choose carefully, not just the money wise. Humidifier used to be the researcher recommend to switch off the humidifier while delivering the aerosol. This was based on in vitro study. Nothing was based on vivo study until we tried to compare delivering at dry circuit and delivering at humid circuit. We find no significant difference at all. When we use it with CPAP, no significant difference. When we use it with BiPAP, single limb, no significant difference. When we use it with invasive ventilated patient, dual limb, no significant difference. We didn't even find any significant difference on the clinical state of the patient getting the dose by dry circuit or humid circuit. We attribute our result that the ventilation circuit, when we switch it off, it continue having the water or the humidity for 20 minutes. Beside the patient exhalation have water as well. So why switching off the humidifier while delivering it? Just risky to the patient with no reason at all. The gas density, the lighter the gas, the better the delivery. Okay, so when you use a mixture of helium and oxygen, 70-30, it delivers much better than oxygen. However, when we use this mixture to make the jet stabilizer work and deliver the aerosol, it doesn't work very good. So the best drug delivery is recommended to operate jet nebulizer by oxygen and deliver these aerosol by helium. So the delivery is by the lighter gas and the operation by the oxygen itself. Patient interface, you'd better use an interface that doesn't leak at all. Choose carefully, or when you put the patient on the ventilation, check the leakage if there is. Aerodynamic character of inhaled aerosol. The idea is the aerosol release is just you can divide it into three parts. Less than 1 micrometer, between 1 and 5 micrometer, higher than 5 micrometer. Higher than 5 micrometer is deposited in the mouth, making the side effect. Between 1 and 5 micrometer is inhaled and deposited in the lung. Lighter than 1 micrometer is released by the exhalation of the patient. So the aerosol, the aerodynamic character of the inhaled aerosol is very critical actually. Patient position, simply try to put the patient on the 30 or 45 degree sitting position to when delivering aerosol, because delivering aerosol when the patient is lying down the bed is not very good. Besides, the patient might ingest some of the delivered aerosol. Ventilation related factor, you have three options: spontaneous mode, pressure assisted control, volume assisted control. The spontaneous mode is the best, followed by pressure assisted control, followed by volume assisted control. The meter doesn't matter at all, because you release the dose while the patient is inhaling. Another patient that might be benefit from aerosol delivery is the high flow nasal cannula patient. This is a new technology actually to merge the aerosol delivery method to the high flow nasal cannula. It's simply better for the patient, more compliant for the patient, and more comfort for the patient. The delivery using this is based on two things: the aerosol delivery position within the setting, the oxygen flow. The lower the oxygen flow, the better the delivery. The higher the nasal cannula side, the better the delivery. The factor affecting the aerosol delivery within high flow nasal cannula is oxygen flow rate, aerosol generator and position of it, type of the humidifier, gas density, and the interface. Aerosol, the gas flow rate, the higher the gas flow, the lower the delivery. So try to lower the gas flow before delivering the aerosol and through delivering the aerosol, and then raise it back out. This is not actually significant when you talk about infant delivery, because infant flow is actually 8 liters per minute. So in the adult, try to use flow at 10 liters or 5 liters, then return to the normal setting. Aerosol generator, you have two aerosol generators, meter dosenator with adapter and nebulizer. We tried all the meter dosenator and all the nebulizer, and we found out that nebulizer is much better delivery than meter dosenator with space. The position is either 3 positions: next to the cannula, before the humidifier, after the humidifier. And before the humidifier was the best method because it filtered down the aerosol large particle in the humidifier. So this position in the middle is the best. Type of the humidifier, we have two types of the humidifier. The first type of the humidifier have the 3 position. The second type of the humidifier, which is obvious here, has only the first position. And actually most of the aerosol delivered to the patient using the second humidifier is thrown away, but the first humidifier is much better than the second when we talk about aerosol delivery. The gas density, like the ventilated patient, the lighter gas is much better than the heavier oxygen gas. So try, when you deliver aerosol, try to use lighter gas like hexane or helium or something like that. Interfaces. Some patient has the mouth breather, so they're not possible to use the nasal cannula. So either use mouthpiece or face mask with them, but the compliance is less than the nasal cannula method. After this, if the physician read a publication and decide upon is actually wrong, so we should have a recommendation and guideline for these. And developing a recommendation and guideline should be done by trusted board and society. So after all what we've done, dependable guidelines are needed to optimize aerosol delivery, which actually is going on progress after what we've done. This is the cover of the World Journal of Respirology, but actually the picture is wrong, because the true picture should be like that, because the work we've done is based on 18 young members and 1 old, which is me. This is the true picture. Thank you.